Guys, welcome back to another video, and I'm going to be explaining the rocket altitude simulation version 2 project of mine. So last video I explained rocket simulation version 1, which did not account for gravity, did only accounted for Earth, and plus not much user interactiveness. So in this version I changed all of that, I fixed those things and I made it better. So if this is your first time watching, I recommend that you go to version 1, especially if you're a beginner, so that you can understand the core concepts and the baseline of this entire project. And plus, if you're a beginner, it's mostly beginner concepts that you learn when you're starting to learn Python, like arithmetic, printing, text, libraries, and all that. So I would highly recommend that you go to that. But as I said, all my code is available in my GitHub. So, and you might be wondering why there's so many projects in my GitHub. Is because like I made a new project and I forgot to make the video on them, so I will be making those videos very soon. And as I said, and I say this in every video, if you have any questions, comments, and concerns, don't hesitate to drop it in the comments. I will answer as soon as possible. And if many people have the same question, I will make a video. Or if it's too long to explain in text, I'll make a video on it. So let's actually test this thing. So let's go. So we're gonna click this play one, and so right now, as you can see already, the in the last version, there was no you couldn't like the user could not change the acceleration of the rocket. This time you can. So right here, if you see right here, uh, I'll just highlight it because there's a lot going on right now. This one right here, basically, it's asking to type in your thrust acceleration. So I'm gonna say around 40. Sorry. So this new feature I added is not now I'm not only accounting for Earth, we're accounting for every planet in the solar system. And now you might be wondering, how are you accounting? What's changing? It's the gravitational acceleration of each and every single planet, and how it's actually affecting the rocket is how it's going to vary based on the planet. So let's just go Earth on it for right now. So Earth, how much time do you want the simulation to run for? I've added this one too. In the last video, as you saw, I explained that you could only do it for 20 seconds, or you could only do it when you change the actual number on the code. But this time you can actually change it and you can put as much as you want. So I'm gonna just say 30. That's basically 30 seconds, just saying. So let me click enter. And as you can see, it's working perfectly fine. And it's not only accounting for just thrust and acceleration, it's actually accounting for gravity. So that's a huge plus. So now let me actually explain the code. This is where it all comes to play. First and foremost, I say this in every single code programming video. The most important is the libraries. Import time. This was in the last version too. As I said, it's extremely important because in this project, time is a big parameter that we need to use. And if you don't do that, then Python won't know that you want to use time and your project just won't work. So that's a very important line. Line one, import time. So now let's talk about the rocket parameters. This all seems really confusing, but the moment I explain it is going to be extremely easy. So these were all there before, thrust acceleration and all that stuff. But if you really notice here, I say thrust acceleration equals flow input da 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 da. So what I'm saying here is that I'm asking the user to type in the thrust acceleration, and whatever the user types in, it's going to be loaded into the variable. And I hear a lot of people ask me, why do you use float? Why can't you use integer? You could use it. But the thing is, if someone puts a decimal, an integer is only a whole number, so you can't really use decimals. That's why you use floats. So that's why I'm using a float here. So right here, planet input, what planet is the rocket in? Here, I'm not adding a float because it's a string value. It's a letter of a planet. It's like the word. So that's why we don't add we don't add anything because if you don't add anything, the computer just assumes you're talking about strings. Now, that's basically what thrust acceleration planet is. It's just asking for user input, and whatever the user inputs is going to be loaded into the variable, and the variable is going to store that in its head. So now here, if you look through 7 through 13, this is where people like this looks a little confusing. They look like it's like random numbers with variables. These are all variables, by the way. These Earth underscore gravity, Mercury underscore gravity. These are variables. This is the gravitational acceleration of each and every single planet in our solar system. And as you can see, Earth's gravitational acceleration is 9.81, and Uranus's is 8.69, and so forth. So that's basically what that is, and it's just storing values. And I just don't like typing numbers. I just like typing words for some reason. You don't need to do this, by the way. Instead of doing this whole gravity equals Venus underscore gravity, you could have just typed the number. I prefer just loading into variables because I feel like it makes it easier for me. You can obviously change that. So if you don't understand what I'm trying to say, this whole thing, this whole 6 through 13 is not really necessary. I like doing it. You could very well just say gravity equals, if you look at line 15, gravity equals 3.70. You don't have to write gravity equals Mercury gravity. I like it because it makes it more organized and simple. So it's your choice. So basically, this is just loading, and this the variables are just basically saying, okay, 3.70 is for Mercury's gravitational acceleration. So that's based. So this whole part is just the gravitational acceleration for each and every single planet. So now 14 through 29, I believe, is looks a little confusing, but is really not. So if you see this, it says if planet equals to Mercury. Now, what does equals to? Why is there equals to? So when we have an equals to, this right here, is just saying gravity is this. But when you have two equals to, it's like comparing something. So is the planet, is it comparing to Mercury? Is this what it says? And if so, it'll display the value. So this two equal signs basically means, okay, this is a comparison. But in the second line, it's just saying once it is the comparison and we realize it's a comparison, then take gravity, take the variable, and load it with Mercury's gravitational acceleration. That's basically what it means. Or you can just say gravity if planet equals Mercury, if planet compares to Mercury, gravity equals 3.70. That's also a simplified version. I just wrote the variable as I'm saying. So this whole part is just the if and else statements. And when you're doing the first if and else statements, you have to do all the rest have to be else and if statements. That's just how it works. And that's basically this whole part, the 14 to 29. That's all that is. So now we're gonna go to this part, net acceleration. So in the last video, in version 1, we were just accounting for thrust acceleration. But now we need to account for net acceleration, which basically means the acceleration which your rocket is providing minus all the gravitational forces. That's basically what net acceleration means, and we need to calculate that. So very simple subtraction happening here. Whatever's the thrust acceleration, remove whatever the gravity is. So let's say the thrust acceleration is 100 and we're accounting for Earth's gravity, reduce 9.81 to get the actual acceleration of the rocket. That's basically what the net acceleration thing is. Very simple. 3536 is obviously just the text just to make it look pretty. Oh, just to say it's a rocket altitude simulator. Very easy stuff. So now 38. 38 is simulation input. This is another input where I'm asking the user how much time do you want the simulation to run for? And it's when it's asking, and when it asks it when the user types in the value, it loads that amount of seconds into the program. So calculate altitude. See, as I said again, these look very confusing, but if you really think about it, it's just a quick Google search. What's the equation to calculate altitude? It'll give you the equation, and that's how I basically do it. These I don't know what the symbol's called, but the ones I'm highlighting right now, these asterisks I think, but in Python there's basically multiplication, and then you might be wondering why there's two asterisks here. The two asterisks means it's squared. So it's time elapsed squared. So these two, calculate altitude and calculate velocity, are simply equations. And these look like the most confusing part because I feel like everyone thinks the math of the program is the most confusing part. Really, it's not. It's just a quick Google search that I did. And just a quick Google search just to remind myself what these equations are because sometimes we can forget. These equations are very simple to understand, but sometimes we forget the smallest details like the squared, and that's what you need to search up. And it's always better to just verify before you actually publish your code. So example, if I didn't actually Google it and I just published my code on GitHub, you guys would be getting wrong data, I would be getting wrong data, and I would just sound stupid. That's basically why you should just Google it, and it's just a quick Google search. It looks confusing, but it's not. Finally, this also looks very confusing, but the 47 through 50, yeah, sorry, 47 to 49 is a lot of letters, and it just looks confusing, but it's not. It's simply formatting of the text. So F is an F string, and that's basically indicating it's an F string. And this colon indicates like, wait, no, sorry, these time, altitude, and velocity is what you actually see in this thing. So see, time, altitude, velocity. That's what that is. And this 6.1F, all that is just uh, decimals. It's trying to say how do we format these decimals into place. And all these things, these meters and meters slash seconds are all just time. And we use meters slash seconds because that's the SI unit. So then finally, time.sleep 0.2, I explained this in the last video too. It just creates a 0.2 lag between every single value. It just makes it look like it's loading all of a sudden. It's aesthetic purposes. You don't need to add it. I added it. It's your choice. But basically, that is Rocket Altitude Simulator version 2. So in the next version, I've already posted the version, but I'm adding a brand new parameter, which is the air density, which is a huge factor in rockets. But the thing is, I am not going to do every single planet. That'll be for version 4 probably because it's going to take a way too long time, way too much time. And I'm going to just account for Earth's air density when we're doing that. So if you're going to be copy pasting the code from the next one, just make sure to use the Earth so you can get accurate data. But basically, this is version 2. As I said, all my code that I ever post on this channel and I will be posting on this channel is in my GitHub. If you have any comments, questions, concerns, comment below. And that's it, guys. Thank you, and I'll see you in the next one.